All right, we're going to look at implicit differentiation. So, we have been seeing functions so far in explicit form, right? We've seen y equals 2x plus 1, or f of x equals x squared plus 4x minus 12. And all of these have been where the output is on one side and the input is on the other. All right, so this is the explicit form. Implicit is something like x squared plus y squared equals 16, right? The y value is not isolated. We could isolate the y value and then do a derivative, but we can also just differentiate with the implicit differentiation technique. So it just adds in a little extra piece. So when we're doing derivatives, we're doing it with respect to x for the most part, or maybe t. We're doing it with respect to one variable. So we've kind of been doing it all along. Like when we have y equals that 2x plus 1, if we've done the derivative, we say, hey, that's y prime equals 2. This y prime here, we were really taking the derivative of y with respect to x. So that's why we have maybe dy dx. But think of like how x, the derivative is just 1. We have y, the derivative is just 1. We just have this extra piece here of y prime, right? So every time we differentiate an equation, if we have a second variable in there, we can do our normal rules. So let's say we have y squared. I could do my normal power rule and say that's 2y. And because I'm typically doing this with respect to a totally different variable like x, I also need to add in that derivative. It's that chain rule piece. All right? Because we're assuming that y is defined implicitly as differentiable function of x. So that's why we have to incorporate that, right? So let's look at a few examples here. So find dy dx for this function here at this point. So this first part, that's a product rule. So that's left d right plus right d left. So left function times derivative of the right, which is just y prime, and then plus the right function times the derivative of the left. And then the derivative of y is going to be 1, and then y prime, and the derivative of a constant is 0. And now we want to isolate the y prime. So I'm going to leave anything with the y prime on the left, and I'm going to subtract y on the other side. And then I can factor out a y prime, and I'm left with x plus 1 equals negative y. And then I can divide both sides by that x plus 1. So y prime is negative y over x plus 1. And then I'm going to evaluate it at 3, 2. So what I do is I throw a vertical line here and then write the point 3, 2 so that I know, all right, I am plugging in this 3, 2. So negative 2 over 3 plus 1. So it'll give me negative 2 over 4, which is negative 1/2. Right. Let's do another one. All right, so we have 1 plus and another product rule. So left times derivative of the right plus right times derivative of the left. And then power rule here, so 4y, but then I also have to add in that y prime, and then equals 0. And I can isolate the y prime again. So I have 3x y prime minus 4y y prime. And I'm going to move everything else. So subtract 1 and subtract 3y. Then I can factor out y prime, left with 3x minus 4y. And then I can divide both sides by 3x minus 4y. So negative 1 minus 3y over 3x minus 4y evaluated at 1, 1. So we get negative 1 minus 3 times 1 over 3 times 1 minus 4 times 1. A lot of ones. So negative 1 minus 3 is going to be negative 4. And then I have 3 minus 4. So negative 1 for a final answer of 4. All right. Sometimes we might have functions where it doesn't have us evaluated at a point. We just want the actual derivative. So let's do it here. So we're going to have 3y squared y prime plus 10y y prime minus 5y prime minus 2x equals 0. And then we just want to isolate the y prime. So I don't want to rewrite it. So I'm just going to add the 2x over, right? Then I can factor out a y prime, and I'm left with 3y squared plus 10y minus 5. And then I can divide by that whole quantity here. So 3y squared plus 10y minus 5. And I'm left with 2x over 3y squared plus 10y minus 5. Now I've been using y prime. I know this says find dy dx, so I guess to match the notation I should have it dy dx. I feel like that's just a lot to write every time, so that's why I've been writing the y prime. But they mean the same thing. All right, let's try this one. So I got another product rule here. So left times derivative of the right plus the right times the derivative of the left. And 3 pi is just a constant, so the derivative is 0. And then I can subtract y e to the x over, and then divide both sides by e to the x. So that y prime is actually just going to be negative y. All right, another one here. All right, we have natural log, and then we have a product rule inside. So this is a u prime over u scenario. So u prime is the derivative of that inside. So left times derivative of the right plus right times derivative of the left all over u, which is just xy, and then equals 1 plus, and then 3y prime. Let's isolate the y prime. So I need to multiply both sides by xy. So I have xy prime plus y equals, and I'm going to distribute that. So I have xy plus 3xy y prime. And I want to move some things over. So I want to get the y primes on the same side and everything else to the other. So minus 3xy y prime equals xy minus y. Factor out the y prime. So I have x minus 3xy equals that xy minus y. And then divide by that whole quantity x minus 3xy. So the y prime is xy minus y over x minus 3xy. Right. Let's do this one. So product rule, left times derivative of the right plus the right times the derivative of the left, then minus 2, 5x to the 4th, and 12y squared y prime. All right, let's try and clean all this up. I want the y primes on one side and the rest on the other. So I'm going to combine some like terms here, multiply these together, make that an 8x squared y prime. And then I want to subtract 12y squared y prime over. And then I've got 5x to the 4th minus 8xy squared plus 2. I want to factor out the y prime, 8x squared y minus 12y squared. And then I can divide both sides by that 8x squared y minus 12y squared. So y prime is 5x to the 4th minus 8xy squared plus 2 all over 8x squared y minus 12y squared. All right. So we have another function, and we want to do some more things with it. So find the equation of a tangent line at x equals -1, and then we want to find the normal line as well. So just remember, the normal line is perpendicular to the tangent line. All right, so what do we need for an equation? We need a point and a slope, because our equation is going to be y equals m times x minus x1 plus y1. So a point and a slope. We can get the slope by doing the derivative at a point. So we can find the y value first, or we can find the slope first. The order doesn't matter. I like to find y first, so I'm going to do that. So x squared minus x times y plus y squared is 7. So let's see what we have here. So that's going to be 1 plus y squared equals 7. I'm going to want to move that 7 over, and I think if I rearrange things, it might look a little nicer. So y squared plus y, if I subtract 7, I'll get -6, and then equals 0. I think I can factor that. I think I can find two numbers that multiply to -6 and add to 1. So +3, -2, right? Which that would give me -3 and +2. So it means I have 2 points. So one point is -1, -3, and the other point is -1, 2. So it means I'm going to have 2 lines for each. So, okay, let's find the derivative. So we have 2x minus, I like to leave it as a minus and distribute the negative later for this product rule right here. But I guess you could keep it as a -x and then a +y. But so left d right plus right d left, and then 2y y prime equals 0. And then because I have my, well, no, I'm going to isolate it. So I've got 2x minus xy prime minus y plus 2y y prime equals 0. Let's rearrange some things, keeping the y primes on one side. So I can isolate it, or factor it out so I can isolate it. And then divide both sides. Because I'm out of room, I'm just going to go ahead and divide it. So -2x plus y over -x plus 2y. All right, and so I have to plug in the 2 different points. So I'm going to do it in different colors. I'm going to do this one in blue. So I've got that y prime is going to be -2 times -1 plus -3 over -1 plus 2 times -3, which will leave me with, let's see, it's going to be 2 minus 3 over 1 minus what is that, 6. So negative 1 over negative 5, which is a positive 1/5. So if I do my line, I'll do it here, y equals my slope, so 1/5, x minus the x value plus the y value. And might as well go ahead and do the normal line for it, right? If our original slope is 1/5, then perpendicular, or the normal slope, I guess I should put the perpendicular sign here, would be a negative 5. So I have y equals negative 5 times x plus 1 minus 3. All right, and I'll do the other line here. So y prime is negative 2 times negative 1 plus y over negative 1 plus 2 times 2, which will give me, let's see, that's going to be 2. 2 plus 2 is 4. It's going to give me 1. 1 plus 4 is 5. So that equation is going to be y equals 4/5 times x plus 1 plus 2. And then that normal line, so 4/5, and then perpendicular is going to be negative 5/4. So y equals negative 5/4 times x plus 1 plus 2. Right? I find the equation of a tangent line for this function at this point. So good, gives us a point. So I just need my slope to make my equation. So derivative. So product rule right here. So left times derivative of the right. So that's 2e to the 2x plus right times derivative of the left. And then 3y prime plus 2x. All right, got a lot going on here. I might, just because I have the point already, I might just go ahead and plug everything in and then isolate the y prime at the end, because that's something we can do. So that's 2 times y squared, so negative root 2 squared, times e to the 2 times 1 plus e to the 2 times 1 times 2 times negative root 2 times y prime equals 3y prime plus 2 times 1. Let's see what we can do here. So that is going to cancel out the square root. And then 2 times 2 is 4. So that's 4e squared plus, I guess I should really say minus 2 root 2 e squared y prime equals 3y prime plus 2. And let's move some things around. So 4e squared, I'll minus 2, and then I have 3y prime plus 2 root 2 e squared y prime. I can factor out that y prime to then divide. So I have 4e squared minus 2 over 3 plus 2 root 2 e squared to be that slope. And I'm going to get a calculator for that. I don't know what all that off the top of my head is. And I'm going to round to 2 decimal places. So 4e squared minus 2, 4e squared minus 2 divided by 3 plus 2 root 2 times e squared. I get that it's about 1 point, and I lied, I'm going to round to 3. Just because the number is 1.153 and then 0087 and it keeps going. So I'm going to leave it at around 1.153. So y equals that slope, 1.153 times x minus 1 minus the square root of 2. There's my equation of a tangent line. All right, find the points at which this graph has either a horizontal or vertical tangent line. So let's put a little thought up into it. So if we are looking at tangent lines, right, we're going to be looking at derivatives. Right? If we have a horizontal, that means my slope is 0. So derivative set equal to 0. And then if I have a vertical, that slope is undefined. So let's see what we can do here. So we have define a derivative. So that's going to be 2x plus product rule left d right plus right d left plus 2y, y prime is 0. Let's isolate y prime. So I will be subtracting 2x, subtracting y, isolating the y prime, or factoring it out, sorry, so x plus 2y, and then I can divide all of that. So y prime is negative 2x minus y over x plus 2y. All right. Okay, so here's our derivative. We want to set it equal to 0 to find the horizontal. So 0 equals negative 2x minus y over x plus 2y. I can multiply both sides by x plus 2y and be left with 0 equals negative 2x minus y. And what I'm going to do here is I'm going to add y to both sides and say that, hey, y is going to be negative 2x. How this is going to help us is because I'm going to go back to this original equation and do some substituting. So I'm going to say, hey, y equals negative 2x. So x squared plus x times y plus y squared equals 27. So I have x squared minus 2x squared plus 4x squared equals 27. So let's see, 1 minus 2 is negative 1, plus 4 is 3. So 3x squared equals 27. Divide both sides by 3, and take the square root. So I have 2x values, positive and negative 3. And then if I know what x is, right, I can find y. I could go back into the original and solve for it, or I found that y was negative 2x. So my points here for horizontal tangent lines are going to be 3 and negative 3. And then let's plug in. So 3 times negative 2 is negative 6. And negative 3 times negative 2 is positive 6. So there's my horizontal. Now, the vertical ones is where the derivative is undefined. So that's going to be the denominator, right? So the denominator is that x plus 2y set equal to 0. I'm going to do same thing here. I'm going to do with the x, though. I'll subtract 2y, right? So I have x equals negative 2y. And I'll keep that in mind here, right? So I'll go back to the original. So negative 2y squared plus negative 2y times y plus y squared is 27. So that's going to give me 4y squared minus 2y squared plus y squared equals 27. So 4 minus 2 is 2. 2 plus 1 is 3. Very, very similar, right? So y squared is 9, and y is now plus or minus 3. So if I look at my points, I'll write vertical here. These are the y values, 3 and negative 3. Well, I can go back to where x is negative 2y, right? So if I plug in 3, I get negative 6. And if I plug in negative 3, I get positive 6. Looks very similar to the horizontal ones, just kind of flip-flopped. But there we have the points. Alrighty. And yeah, that is actually all for implicit differentiation. So if you have any questions, let me know.